In today's lesson, we're going to be talking about sequences. And one of the first things I want to go over is the difference between an infinite and a finite sequence. So let's say we had a sequence that looked like this: 2, 4, 6, 8, 10. This is an example of a finite sequence. And it is a finite sequence because it's composed of 5 terms. This is our first term, this is our second term, this is our third term, our fourth term, and our fifth term. And this sequence only has 5 terms. There are no other terms that come after this fifth term here. So this is known as a finite sequence because it has a definite end. Then we can have a sequence that looks like this. Let's say we have 1, 4, 7, 10, 13, and we have 3 dots following the sequence. This is known as an infinite sequence. And the reason it's an infinite sequence is because of these 3 dots here. This is going to signify that the sequence does not end at this fifth term, and that it indeed goes on and on and on way past this fifth term and has no definite end. And so this is known as an infinite sequence. Another thing that we can notice in each of these sequences is, well, at least in the first sequence, we can see that when we go from the first term to the second term, we're adding 2. When we go from the second term to the third term, we're adding 2 again. When we go from the third to the fourth term, we're adding 2. And when we go from the fourth to the fifth term, we're adding 2 again. So in this sequence, we are going to add 2 each time we go from one term to the next. Whereas in this one, we're going to be adding 3 as we go from one term to the next. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, and 10 plus 3 is 13. So this sequence is going to go on and on and on, adding 3 each time we get from one term to the next. Now let's say you were given the following sequence: 3, -9, 27, -81, 243, -729. Now, when we look at this sequence, it's different from these two in that we're not going to be adding or subtracting a specific number each time. And what you have to remember is that if we're looking for a sequence and what's happening from one term to the next, we actually have to be looking for a pattern, and it has to be a pattern that repeats every time we go from one term to the next. And we don't see a pattern here where we can add or subtract a number to get from one term to the next. You can see that the difference between these two is very large compared to the difference between these. So this sequence can't be described by simply adding or subtracting a certain number to get from one term to the next. But what we do notice is, firstly, that we have an alternating positive and negative sign in this sequence. Every other term has a negative sign. And when we see a sequence where every other term has a negative sign and we have an alternating positive and negative, one thing that this could hint to us is that we are probably going to be multiplying by a negative number to get from one term to the next. And we can tell that because let's say we started off with our first term here. If we were to multiply this positive term by a negative number, we would get a negative number as a result. And then if we're multiplying a negative number by another negative number, we're going to get a positive number. And then again, that positive number multiplied by a negative will give us a negative. So when we see something that's an alternating positive and negative, it could be a sign that we're multiplying by a negative number. And another thing that we might notice is that to get from the first term to the second term, we've multiplied by 3. To get from the second term to the third term, we've also multiplied by 3. To get here, we've also multiplied by 3, and that's actually going to be the the repeating pattern that we have here. Each term is going to be multiplied by -3. So instead of just adding or subtracting numbers, here we actually have a common factor. We're multiplying each of our terms by -3 to get to the next term. Now there's one more thing I want to go over, and that is just some terminology when we're talking about sequences. So let's say we had the following sequence: 1, 4, 7, 10, 13. This sequence is made up of 5 terms, and when we describe each of the terms, we're going to write down each term as a T with a subscript, and that subscript is going to tell us which term we're referring to. So T1 is how we're going to write our first term, and T1 in this case, our first term, is equal to 1. T2 is how we're going to describe our second term, and T2 is our second term here, which is equal to 4. Then T3 is going to be our third term, which is 7. T4 is our fourth term, which is 10. And T5 is our fifth term, which is 13. So we can actually describe, let's say this continued to go on until our nth term. We can describe our nth term as Tn. And it's important to understand the difference between Tn and n. In this case, let's say we had T2, our second term, is equal to 4. So our n in this case is 2. We're talking about our second term. But our T2 or our Tn is going to be the value of that second term, which in this case is equal to 4. When we're dealing with sequences, we're going to want to be able to find a general formula that can describe a sequence. So if we had to find, let's say, the 21st term, we would be able to easily plug that into the general formula we have that can describe any term in this sequence, and that would save us a lot of time and not having to write down every single term up to our 21st term. We could just find a general formula for a sequence and use that to easily be able to find any term within the sequence, even if we were looking for the 200th term. So let's try to do that with this sequence here. Is there a way that we can write down a general formula that can describe any term within this sequence? Well, one thing that we can notice is that when we're going from one number to the next, we are adding 3 each time. So each of these terms, we're going to be adding 3. Let's see if we described this sequence as 3n minus 2. Well, let's try to use this formula and see if we try that with each and every one of our terms, if it actually works. So using this formula, T1 would be equal to 3 times 1 minus 2, and that would be equal to 1. T2 would be 3 times 2 minus 2. That would be 6 minus 2, which is 4. T3 would be equal to 3 times 3 minus 2, and that would be 7. And we can give ourselves a little bit more room here. Let's try that with T4. T4 would be 3 times 4 minus 2, which is 10. And T5 would be 3 times 5 minus 2, which is 13. And if we look at this, 1, 4, 7, 10, 13, that is exactly our sequence here, 1, 4, 7, 10, 13. So we have actually found a general formula for the following sequence, and that formula is 3n minus 2. And because of this, we can use this formula now. Let's say we wanted to find the 200th term. If we wanted to find the 200th term, we know that our n would be equal to 200, so we would do 3 times 200 minus 2, and that would be equal to 598. And that is a lot easier than writing down each and every one of our terms, adding 3 to each of these terms 200 times until we get to our 200th term. obviously finding a general formula for our sequence that's going to describe any number in our sequence is going to be a lot easier and save us a lot of time.